filters for unclean air, all sorts of other things. And more importantly, support for DC power. So this is what you see implemented in a lot of telecom data centers that run on DC power, and then a lot of vehicle type environments like military environments where they have DC power available. So like you see those on naval ships, you see them in Humvees, you see them deployed in a lot of factory environments, things like that. But internally, they're basically the same technology as the original Bladecenter E and the original Bladecenter H, and take the same blades. Over here, the newest member of the family was released a couple of years ago, the Bladecenter S. And this is a more specialized solution. It's a smaller footprint chassis holding 6 blades, as well as capacity for internal storage. So you can basically get now not just consolidate your SAN networking, but also SAN disk into that chassis as well. And this is meant for smaller deployments in remote offices, small offices, where you don't have a data center infrastructure to support systems that you need to keep at some remote location. The Bladecenter S is a good fit for that. They even sell kind of a midget rack called the Bladecenter Office Enablement Kit. That's a nice acoustically sealed tiny rack that you can stick in a corner in an office environment or in a wiring closet somewhere, which is what we see a lot of times. And it can run silently. It plugs into normal 110 power. You don't need data center class power to power this Bladecenter. It's meant really for those non-traditional data center environments. And then I kind of forgot to speak to it. Common set of blades, common set of I/O switches and fabrics, common management infrastructure across all those blades. Did lose a slide here, but I'll recover here in a moment. Newest member of the Bladecenter family of products is a new blade that was just announced at the end of last month, part of Intel's overall announcement of their new generation of Intel Xeon processor, the 5500 series. And that's really what this new blade is designed to take advantage of, the new Bladecenter HS22. So this is now the new premier Intel x86 Intel Xeon blade offering, general purpose blade offering from IBM for the IBM Bladecenter. Looking at where it fits with relation to the existing portfolio. Here I'll kind of go into the portfolio of blades. You basically have Intel Xeon covered, AMD Opteron, and even power and even some other specialized appliance blades as well. A very broad portfolio across multiple processor platforms, something that really only IBM brings to the table in their blade offering. The newest member, which is really now the general purpose workhorse of the Bladecenter portfolio, is the HS22. This is the new dual 2-socket Intel Xeon blade. Pretty much covers the broadest spectrum of applications for your Intel Xeon. At the lower end, you have a single socket blade, the HS12, available for low cost, low end, low performance requirement solutions. Looking at the rest of the platform for high performance computing, you have AMD Opteron offerings in the LS22, which is a 2-socket, and LS42, which is a two blade, 4 sockets in a single system image offering in AMD Opteron. And then finally, and you probably already heard a little bit about these, JS12 and JS22 being your 1-socket and 2-socket Power 6 blade offerings. They will run AIX, Linux, and the IBM I operating system. So here's the HS22 in detail. And really the key enabler of this new blade is the new Intel 5500 series of processors. So 2-socket blade with 2 of these Intel Xeon processors, and in addition to the significant, very significant performance gains you gain from the new architecture enhancements in that series of processors, IBM kind of redesigned the basic Intel Xeon blade to make it much more efficient, to be able to squeeze a lot more horsepower into the overall system architecture. IBM, as you may have already heard, takes a holistic view to system architecture. They don't just throw faster processors or more of something. They want to make sure that the whole system makes sense. So what other new features do you have in this blade that you didn't have before? Well, they changed the layout of the blade to cool it much more efficiently. You basically have hard drives at the front with your processors, and then your I/O expansion cards in the back. And then in the middle, they've now rotated the memory DIMMs 90 degrees, so that they now align along the blade, as you see here. And this allows for the cooling, the cool air which comes in the front of the blade, to now go across all these components, all these hot components, and cool the blade much more efficiently than they used to do. The net result of which is they can now fit 2 hot swap hard drives per blade at the very front of the blade here, and we now have 6 and 6, so 12 memory DIMMs, which is a significant improvement in the memory scalability over the previous generation of blades, up to 96 gigs of memory per HS22 blade when you use currently the largest size 8 gig DIMMs that are available. So significant enhancements there. Also, and this was already available in some of the previous blades, internal USB, really meant for attaching USB flash drive internally, and the purpose being you can install your embedded hypervisors such as VMware. There's VMware offerings today. There'll probably be other hypervisors offered in the near future as those technologies mature. But integrated embedded hypervisor, so that you don't have to even install your virtualization platform. You just buy the blade, plug it in, turn on your licensing, and you're already up and running in a virtualized infrastructure. I spoke to 12 memory DIMMs, 2 I/O expansion slots, and we do have a new form factor here that I'll speak to in a moment. That's basically how you connect to your I/O fabric, I/O expansion modules in the back of the Bladecenter. Dual redundant power and I/O connectors to the mid-plane of the Bladecenter, which again is that connection between the blades and your I/O expansion modules. IBM being one of the few vendors that every blade has dual redundant connections to everything in the blade offered by the Bladecenter. So no single points of failure in your IBM blades. There's also optional RAID 5 capability if you need that capability with your onboard disks. There's also some expansion blades to add even more internal disks to the blade. You have that capability offered now as well. Like I said, the key performance gain is coming from the new series of Intel Xeon 5500 processors. I'll speak at a high level here to some of the architectural changes. Basically, the main architectural improvement comes from they've now kind of moved a little closer to the architecture you see from some of the higher end platforms such as Opteron and Power. You now have integrated memory controllers on each processor chip, so up to 4 cores and a quad core sharing an integrated memory controller on the chip. And now they implement a high-speed interconnect between all your chips. They call it Quick Path, but it's essentially along the same lines as what you've heard others talk about before. AMD calls it hypertransport, Power calls it the GX bus. But basically, very high-speed interconnect between your chips. Dedicated paths from the integrated memory controller to your memory on each chip, not having to go out through various levels of cache or other ways. This new architecture, much more memory bandwidth efficient, and that's where a lot of your performance